yesterday we talked about the tangent ratio, and we talked about when we have a right triangle, the tangent ratio was the opposite leg from the angle over the adjacent leg to the angle, right? And the hypotenuse is always the hypotenuse, so it cannot be an opposite or an adjacent. Well, so today we're going to talk about the other two trig ratios, and they are called sine and cosine. We don't call them sin and cos, and we don't call tangent tan. Those are abbreviations, okay? It's sine and cosine and tangent. All right. So if we're taking the sine of an angle, it's going to be the opposite leg over the length of the hypotenuse. And if we're finding the cosine of an angle, it's going to be the adjacent leg length over the length of the hypotenuse. So SOHCAHTOA, so y'all say that, SOHCAHTOA is one little acronym that we can use to help us memorize the ratios. Now, you got to be able to spell SOHCAHTOA for it to work for you. Okay, so it's an acronym. So that part is referring to sine, and it's going to be the opposite over the hypotenuse. Okay, the ca part is talking about cosine, and it's going to be adjacent over the hypotenuse. And then TOA refers to tangent, and it is opposite over adjacent. Okay, so if you can remember how to spell SOHCAHTOA, then that will help you know which legs and hypotenuse go with which ones. All right? All right, so first we're going to practice finding some sine ratios. And we have this triangle. It's a right triangle. Okay? And we're going to practice finding the sine of angle S and then the sine of angle R. We have already checked our calculators to make sure we are in degree mode. So that's very important when you're doing trig ratios, as we figured out yesterday. Right? Yeah. Miss Isabel made that boo-boo. Put that on the bloopers. All right. Hashtag bloopers. Go find them. I'll make that video one day. All right. So, sine of angle S. Well, here's angle S. Sine is the ratio of what over what? Right. So sine of S is going to be its opposite over the hypotenuse. Now, the hypotenuse is the hypotenuse for every angle. Okay? The hypotenuse is always the longest leg of the right triangle. It's always the leg or the length that is across from the 90-degree angle. So what is the hypotenuse of this right triangle? 65. Okay? So, to find sine, I need the opposite leg from angle S. So here's S up here in the top. So which is the length of the leg that's opposite S? 63 is its opposite. Because it's not touching it and it's not the hypotenuse. Okay? Well, the hypotenuse is touching the angle, but still. It's the one that does not touch it. So when I set up my ratio, I'm going to say sine of angle S equals 63 over 65. So I plug in the length of the leg opposite and the length of the hypotenuse. And then we can type that in and get a decimal. So in your calculator, type in for me 63 divided by 65. Yeah, so we're going to round that to about 4 decimal places. So sine of S is approximately 0.9692. So if it's a big long decimal, give me 4 decimal places, please. All right, so now we're going to do the same thing, except for we're going to find the sine of angle R. Sine of angle R. So my opposite's not going to be the same, is it? No, because angle R is down here. I need everybody paying attention. So angle R is down here. What's the length of the leg? Again, sorry, that's opposite over hypotenuse. I need to put that. What's the length of the leg that's opposite from angle R? 16 is opposite. And the hypotenuse is what? Still 65. So type in and get me the decimal for 16 divided by 65. Yeah, we're rounding it so it's approximately 0.2462. Right? The 5 makes the 1 go up. Now, something you're going to notice about sine and cosine is that the decimal will always be a number smaller than 1. I'm tired of seeing you on your cell phones in my classroom. I got an email this week that says I have permission to write you up anytime I see you using your cell phone in my classroom without permission. And I just saw 2 people within 1 minute. And yes, that's recorded. And yes, it's going on YouTube. And I don't care if your mamas hear it. This is everybody's warning. Okay. So sine and cosine will always be a number less than 1 because the hypotenuse is always going to be the largest side, right? So I'm putting it over the hypotenuse, so that number is going to be a fraction smaller than 1 every time. Okay? So sine and cosine will always be a number less than 1. Tangent can be greater than 1. Tangent can be greater than 1 because the opposite can be larger than adjacent. Okay? But opposite and adjacent cannot be larger than the hypotenuse. All right. Here's another one. We're finding sine again for x and y this time. We got an 8, 15, 17 right triangle. Which one's the hypotenuse? 17. All right. Let's find sine of x. So sine is what over what? Opposite over hypotenuse. So what's the length of the leg that's opposite from x? 8 over the hypotenuse is what? 17. So what's the decimal for 8 over 17? It's approximately what? 8 over 17? 4706. Any questions about that? All right, we're going to do the same thing for angle Y. So for angle Y, what's the length of the leg that's opposite from that one? 15. And the hypotenuse is still 17. So you're going to get 15 divided by 17 as a decimal. Yep, so it's going to be 0.8824. And make sure you put squiggles because this is not equals, we're rounding. Okay? Y'all try this one real quick. Find sine x and sine y for this triangle. We'll do some cosines. Let me know if you get stuck. The water flows. Check your decimals with a neighbor. All right, help me out, please. What is the length of the leg that is opposite from angle X? Sorry. 15 over what's the length of the hypotenuse? And what'd you get for 15 over 25? That's a nice one. It's exactly 0.6. Raise your hand if you got 0.6 for sine of X. All right, sine of Y. What's the length of the leg that's opposite from angle Y? Over what's the length of the hypotenuse? And what's 20 over 25 as a decimal? 0.8. Raise your hand if you got both of those. Those are nice because you didn't have to round. All right, next I believe we're going to work on some cosine. We sure are. So we got another right triangle. And this time we want to find the cosine of angle U and the cosine of angle W. All right, so cosine is the ka part of SOHCAHTOA. So cosine is going to be what over what? Adjacent over the hypotenuse. So we could go ahead and label our hypotenuse because it's the same for the whole entire triangle. It's 30. All right, and our first one is angle U. So remember, adjacent is the leg that touches that angle but is not the hypotenuse. Okay, the one that touches the angle but is not the hypotenuse. So for U, what is the length of the leg that touches that angle and is not the hypotenuse? 18 is the adjacent leg, and the hypotenuse's length is what? 30. So we type that in. 18 over 30 is what? 0.6. So any questions on how we got cosine of angle U? All right, we're going to do the same thing, this time for angle W. And that's going to be adjacent over hypotenuse as well. So what's the length of the leg that's adjacent to angle W? Yeah, it's touching 24. And the hypotenuse of the whole triangle is 30. And so you type in 24 over 30. And it is 0.8. So any questions on cosine? Can y'all try this one? Whoa, can't try this one. What's up with this one? It doesn't have the hypotenuse. Can we fix that problem? How can we find a hypotenuse? Pythagorean theorem. So if it don't tell you one of the legs or the hypotenuse that you need, and they give you two sides, then you can use find the third side using Pythagorean theorem. So I'm going to use a squared plus b squared equals c squared. And are we looking for a leg or the hypotenuse? So we're going to find c. So 9 squared plus 12 squared equals c squared. What is 9 squared? What's 12 squared? What's 81 plus 144? Oh, that's nice. So take the square root and c is 15. So we can use that for our hypotenuse because we need a hypotenuse if we're doing cosine. So any questions about how we got our hypotenuse? All right. Since these are right triangles, the Pythagorean theorem works for us. Okay. So let's start with finding the cosine of angle R. Cosine is what over what? All right. So here's angle R down here at the bottom. What's the length of the leg that is adjacent to angle R? Over what's the hypotenuse? 15. And what is 9 over 15 as a decimal? 0.6. They like that one, don't they? So there's that one. I guess I could highlight it. All right. And then so next we need to find the cosine for angle S. Again, it's going to be adjacent over the hypotenuse. So angle S is up here toward the top. What's the length of the leg that's adjacent to angle S? 12. Over the length of the hypotenuse is 15. And 12 over 15 is what decimal? They like that one as well. That's kind of boring, isn't it? All right. You think we could skip a U try? Y'all got cosine? All right. Now we get to actually find some missing legs like we did yesterday. The thing is, they're not going to tell us whether we need to use sine, cosine, or tangent. We have to decide based on the information that we have which one we need to find. Or which one we need to use, sine, cosine, or tangent. Okay? So this is where you're really starting to do some trig problems. So the angle they gave us was 35 degrees. Y'all agree? So we're going to base everything off of that angle right there. All right. So we're finding x. What is x's relationship to the 35 degree angle? It's actually the hypotenuse of the whole triangle, right? And what's the 11 feet's relationship to the 35 degree? Opposite. So what are we going to use? Sine, cosine, or tangent if we have opposite and hypotenuse? Sine. So you got to determine your relationship between the two things they give you, or the one you're trying to find, and the angle they give you to determine if you even need to use sine, cosine, or tangent, because it's not going to tell you which one to use. So we're going to say sine of 35 degrees equals opposite over hypotenuse, so 11 over x. And we're going to do this very similar to how we did tangent yesterday. All right, we got to solve that equation for x. So we got to get it out of the denominator, so multiply both sides by x. So now I have x times the sine of 35 degrees equals 11. Now what do we do? Divide by the sine. I should be using parentheses, my bad. So x is going to be 11 divided by the sine of 35 degrees. So this is where we get our calculator. And mine is going to sleep, so I'm going to check the mode again. It's still in degrees. Trying to get out of there. So you're going to hit 11 divided by parentheses. Okay, we're going to use the sine button, which is kind of diagonal from your parentheses. 35 degrees. Close my parentheses, close it again. We're getting about 19.2 feet. Did everybody get 19.11 something? 177 actually. We good? Okay, so x is approximately 19.2 feet. Does that make sense? That's supposed to be the hypotenuse, isn't it? Is it longer than the other side we got? Okay, good. All right, we good? All right. Angle of elevation and angle of depression. Why don't you write those definitions for me? And then get out your book. I know it's a little small, so maybe you can read it. If you can't, let me know. I'll read it out loud in a second. 475. line of sight. Do y'all know what that is? Yeah, if I'm looking straight ahead, okay, the line of sight is exactly wherever my eyes are, probably at about 5.5 feet 7 inches from the ground. All right? If I'm looking straight across, it would be like a horizontal line straight across 5 feet 7 inches all the way across. Okay? Probably more like 5'6", because I kind of got a big forehead and tall head. All right. So, your angle of elevation would be if you're looking upward at something. So your angle of line of sight would be looking straight across. Your angle of elevation would be like looking upward or something. So if you're looking like up a hill at somebody. And there's a good picture of that on page 475, actually. There's somebody like on a cliff at the beach where I'd like to be right now, but not in Florida because there's a hurricane coming. All right. And then the angle of depression would be like if you're up high and you're looking down low. Okay, so like if you're at the football stadium and you're looking out at the football field, that would be an angle of depression. You're looking down, right? So if you look on that page 475 at example 4, it's got a guy skiing, okay? So here's our guy skiing. He's got big old skis on. He's got his little, whatever those things, sticks are you ski with. He's probably got a toboggan on because it's cold. He's got a scarf. Yeah, he might need clothes on. It's cold. There you go. Big fluffy skiing. Y'all been skiing before? I stunk at it. I fell too many times. So there's my little dude skiing. He looks cute. And he's skiing down a mountain. And it said his angle of depression is 21 degrees. And it said the distance of his line of sight makes with the ground is 1,200 meters. It wants to know how far he skied down the mountain. Okay? How far did you ski down the mountain? So, do you see how this makes a right triangle up at the top? Right? You can technically ignore the bottom triangle. All right? So, we want to find how far he skied down the mountain, which is actually the hypotenuse of this triangle. Do y'all agree? Yes. And this 1,200 meters from his line of sight with the ground, is that opposite or adjacent from the 21 degree angle of depression? It's opposite. So are we going to use sine, cosine, or tangent? Sine. So we're going to say sine of 21 degrees, since we know the degree measure, equals opposite, which is 1,200 meters, over x, which is the hypotenuse. Sine is opposite over hypotenuse. All right, so we want to get that x by itself. So how do we do that? Multiply by x on both sides. So x times the sine, 21 degrees equals 1,200. Now what do I do? Divide by sine 21. And then we're going to use our calculator to help us out. So 1,200. Turn it on. Hang on. I have to double tap everything on mine. Okay, so this is in meters, correct? So we're going to say we're at about 3,348.5 meters till we get down to the bottom of the mountain. So x is approximately 3,348. Yeah, because if you think about a mountain, I mean, that's a long way, right? So that's a couple of miles, probably. Right? I would roll down the mountain. I'm not a good skier. Okay, if I turn the page, it's got a skateboarder and a ramp. Okay? So example 5 on the top of page 476 has a lot better picture than mine of a skateboarder and a ramp. So this is kind of like if you tilt the ramp sideways and you're just looking at one side of it, okay? So it says you want to build a skateboard ramp with a length of 14 feet. So that means the hypotenuse is 14 feet. And an angle of elevation, so that's looking up from the ground, of 26 degrees. You need to find the height and the length of the ramp. So you want it to be 14 feet of going up, and you need to find this, and this. Can you do them both at the same time? No, you're going to have to do one after the other, okay? So what do y'all want to find first, X or Y? X, the height, okay? So here's my angle. 14 we said was the hypotenuse. So if I'm finding X, is X opposite or adjacent? Opposite. So am I going to use sine or cosine? Sine. So to find X, I'm going to say sine of 26 degrees equals opposite, which is X, over the hypotenuse of 14. So any questions about why we're using sine or why I have it set up like this? Okay, again, they're not going to tell you which one you have to use, so you're going to have to look and see if you have opposite, adjacent, hypotenuse, or what. Okay, so how do I get this one's X by itself? Multiply by 14 on both sides, and this is one that's simpler. Because that's all you got to do is type in your calculator. It's 14 sine 26. You can put times in there, but you don't have to, and it works as well. So you're going to hit 14 times the sine of 26 degrees. Make sure you close your parentheses on your 26. And these are in feet. So that's approximately 6.14 feet, right? Now, let's just go ahead and use the other. There's 2 different ways I can get the last length. Can somebody tell me one way? Cosine, because it's adjacent. Is there a third way or a second way I can find that one? Yeah, now that I know a hypotenuse in one leg, I can find the other leg by using Pythagorean theorem. Okay? However, didn't I round that number? Right? So it's probably going to be more exact for me to use cosine. Okay? Because when we round, we just kind of throw off our accuracy. Okay? So to be more accurate, we could use cosine. So that's what I'm going to do. That, and we can practice finding cosine. So cosine of 26 degrees is adjacent over hypotenuse. So adjacent is their variable over the hypotenuse is still 14. That's a y, not a 4. So how do we get y by itself? Multiply by 14. So it's going to be 14 times the cosine of 26 degrees. And we type that in our calculator. Yeah, so we get about 12.6 feet. So any questions about that? So look, if you have adjacent and hypotenuse, you use cosine. Opposite and hypotenuse, you use sine. Okay, remember, so katoa will help you remember which one to use when. All right, we're going to stop here for the day. Have fun practicing sine and cosine. See you later, math nerds.